Okay, let's dive into this. Welcome to this explainer. Today we're going to unpack a single densely packed title slide. Now, you might be wondering, a title slide? Really? Why are we spending time on that? But trust me on this one. This single document serves as a massive gateway to understanding the absolute bedrock of modern technology. We're looking at the introductory page for a lecture series, and it is just loaded with visual clues, context, and heavy academic weight. So we're going to decode it together, kind of acting like technical detectives to figure out exactly what journey this source material is setting us up for.
So the first thing we see boldly stamped right at the top is the title, Introduction to AI and ML, which brings us to a pretty natural rhetorical question. What exactly are we introducing today? I mean, these are two of the most heavily used acronyms in our modern world, right? They're thrown around in news headlines, sci-fi movies, big tech keynotes. Our source material assumes we're about to study them in deep, rigorous detail. But before we get to the complex math or the advanced programming, we really need to know what foundational building blocks we're actually dealing with here. So here is our roadmap for today. 1. Why AI and ML matter. 2. Decoding AI and ML. 3. The mechanics of thought. 4. Institutional power and technology. And 5. The map, Alpidon's textbook.
Section 1. Why AI and ML matter.
Context is absolutely everything when you're learning a new, highly technical subject. It's so easy to look at computer science as just, abstract lines of code floating in a digital void. But our source material gives us a massive clue that this has real-world stakes. The file containing this information is specifically named Lecture 7, Linear Regression Medical. Now, linear regression is basically just a fancy mathematical way of drawing a line of best fit through past data to predict a future trend. And that word, medical, is our anchor. It tells us we're using those trend-predicting algorithms to solve complex, life-saving problems in the healthcare industry. Think about it. We're talking about using data to predict patient outcomes, analyze complex X-rays, or even tailor individual treatment plans. When we talk about these algorithms, we're talking about tools that are fundamentally reshaping how we approach human health.
Section 2. Decoding AI and ML. If we're going to understand how this technology transforms medicine, we need to establish some baseline definitions. First up is AI, artificial intelligence. I want you to think of this as the grand overarching concept. It's the ultimate goal of creating machines that are capable of human-like intelligence and tasks. Think of it kind of like wanting to build a robotic chef. The goal, the AI, is to have a machine that can operate a kitchen, understand flavor profiles, and serve up a perfect meal just like a human chef would. It's the broad umbrella term for machines doing smart things. Then we have ML, machine learning. Now, this is a specific subset of AI. This is the how. Let's go back to our robotic chef analogy. In the old days of computing, to get a machine to bake a cake, you'd have to explicitly program every single step. Actually, scratch that. You'd have to program every tiny micro-step, crack one egg, apply this much pressure, stir twice, heat to exactly 350 degrees. But machine learning is different. Machine learning is like giving that robotic chef a blank recipe book and a million pictures of perfect cakes and letting it figure out the patterns on its own. It learns through trial, error, and vast amounts of data, without a human explicitly writing out every single rule.
So the absolutely crucial point is this comparison right here. Artificial intelligence is the broad, ambitious goal, the intelligent machine. Machine learning is the specific, data-driven method we use to actually get there. By feeding systems mountains of data, like say thousands and thousands of medical records, the machine learns to spot hidden patterns that even human doctors might miss. That is the core engine driving the lecture we're introducing today.
Section 3. The mechanics of thought.
Now, what's really interesting about this slide is the visual imagery. It tells a story all on its own. Let's examine this first graphic, labeled with the letters AIRC. I want you to picture this. We have a blue silhouette of a human profile, which is the classic representation of the human mind and cognition. But inside the head, instead of a biological brain, it is completely filled with interlocking mechanical gears of various sizes. Some have stars in the center, some have intricate spokes, but they are all connected, turning together to form a single functioning unit right there inside the human mind. This is just a brilliant visual analogy for exactly what artificial intelligence and machine learning attempt to do. It represents the brain as a machine. It's literally a thought factory. In machine learning, complex human cognition, like diagnosing a disease, for example, is broken down into measurable, mechanical algorithms. Just like those interlocking gears, different mathematical functions and data points interlock to produce a final thought, a final decision, or a final prediction. It's the mechanization of thought, beautifully captured in a single logo.
Section 4. Institutional Power and Technology.
Next up, we see a very bold formal crest. It features a striking golden eagle with a shield on its chest, set against a bright red background. But notice the framing here. Behind the eagle are two crossed swords, and the entire crest is enveloped within a massive, dark industrial gear. This is definitely not a whimsical startup logo. The visual language here, the eagle, the swords, that heavy industrial gear, speaks to profound structure, discipline, and serious institutional backing. It signifies that the material being taught here is rigorous, officially sanctioned, and likely backed by a major technical or military-style academy. And putting these concepts side by side brilliantly illustrates the duality of the field we're entering. On the one hand, you have the abstract theoretical pursuit of mechanized human cognition, the dream of the thinking machine represented by the gear-filled head. On the other hand, you have the heavy-duty, highly disciplined institutional application of that theory, represented by the crest. It tells us right out of the gate, we're dreaming big about the human mind, but we're executing those dreams with absolute precision and serious real-world tools.
Section 5. The Map. Alpeiden's textbook.
Every journey into uncharted, highly technical territory needs a reliable guide, right? Well, we are explicitly given the academic map we'll be using for this adventure. At the bottom of the page, it clearly lists the reference book, Introduction to Machine Learning, 4th edition by Atham Alpeiden. For anyone stepping into this field, knowing your primary text is absolutely vital. Alpeiden is a highly respected voice in computer science, and this material serves as the foundational bedrock for the lecture. It means we aren't just guessing how those gears in the brain work, we're following a structured, peer-reviewed methodology to build them.
But the detail I really want to highlight here is the publisher and the year, the MIT Press 2020. MIT Press is globally recognized as an absolute powerhouse for technical, scientific, and computing literature. It represents a total gold standard of academic rigor. And that year, 2020, is crucial. In the fast-moving world of artificial intelligence, a book from 10 years ago might as well be ancient history. A 4th edition published in 2020 means the student is getting modern, refined, and highly updated knowledge that reflects the current state of the art in machine learning.
So let's tie all of this together. We have the foundational knowledge of AI and ML from a premier 2020 textbook. We have the backing of a highly disciplined technical institution. We have the beautiful concept of the mechanized mind, this thought factory. And we know from context that all of this is being pointed directly at the medical field. Which leaves us with one incredibly provocative question as we prepare to step forward. How exactly will these mechanical gears of machine learning ultimately revolutionize the medical field? How will these algorithms learn to save actual human lives? That is the journey this incredible introductory material prepares us for. Thank you so much for joining me on this explainer, and I hope you now see just how much story a single page can tell.